Hello. I do have a video for calculating fractions in your calculator, but last semester I had a student tell me that he really wanted to see how to do it without a calculator. So this is an additional presentation for you if you're interested in learning how to work with fractions without a calculator. So one of the things I try to tell my students all the time is that we do work with fractions without a calculator all the time. We do it without thinking about it. And I think a lot of people are a little bit intimidated by fractions because once they see it on paper, they think they don't know how to do it. But really, you do. So a good example I give is this focus question I ask, which is 25 cents is what fraction of a dollar? Think about it for a second. Hopefully you instantly thought to yourself, a quarter of a dollar, right? 1/4, 25 cents is a quarter. That's why we call the coin a quarter. So we know that 25 cents is 25 cents out of 100 cents. So I could write 25 cents as a fraction. You just say it's 25 out of 100. That's what fractions are. And then what I just did was I wrote an equivalent fraction. I said that 25 cents out of 100 cents is the same as 1 out of 4. So we just reduced that fraction in our heads instantly. Hopefully that makes you feel really good. So lowest terms without a calculator, well, we just did that one. That one was pretty easy. Let's do ones that are a little bit different. And so I use the language of factors when I talk about reducing or putting fractions in lowest terms. And that is to recognize that 2 goes into 6 and 2 goes into 8. 2 times 3 is 6, right? And 2 times 4 is 8. So 6 and 8 have a common factor, a thing that multiplies by something to give 6 and 8. The common factor is 2, because 2 times 3 is 6 and 2 times 4 is 8. So if I have a fraction that is 6 over 8 and I want to reduce it, then I say, what is the common factor? What is the thing that goes into 6 and 8? And the thing that goes into 6 and 8 is 2. So I just divide the top of the fraction by 2, and I divide the bottom of the fraction by 2, and then I get my reduced fraction. So 6 divided by 2 is 3, and 8 divided by 2 is 4. So 6 over 8 is the same as 3 over 4. Here's another one. What number goes into 12 and 16? Now, you could pick the biggest number that goes into 12 and 16, or you could pick any number. These are both even, so I know 2 goes into them. So again, if I divide the top by 2 and the bottom by 2, I will get a reduced fraction. I'll get 6 over 8. But I just did 6 over 8. That was up here. And so I know 6 over 8 can be reduced again because, again, they're both even, so they can be divided by 2 again. Don't worry if it takes you more than one step to reduce. So I do 6 divided by 8. I am not very gifted with this pen. I hope you forgive me. So we get 3 over 4. So 12 over 16 is the same as 3 over 4. Now you could have done it in one step by dividing the top and the bottom by 4, because 4 goes into 12 and 4 goes into 16. So here's 18 over 60, and I want to reduce, and I want to pick the biggest number possible to reduce by. So let me show you another way to do this. I know that I could rewrite 18, and I could rewrite it as 3 times 6, right? And if I wanted, I could also change 6 to 3 times 2, but I'll leave it as 3 times 6. Now 60 I could rewrite as 10 times 6. So the common factor in the top and the bottom is 6. So if I divide the top by 6 and the bottom by 6, they go away, and I end up with 3 over 10. So that's another way you could do it. You could write out the 18 as multiplication and the 60 as multiplication and cancel all the things that are the same. Okay, so I'm going to just talk about baking cookies for a second. I love oatmeal cookies. I've made this recipe so many times I have it memorized, and it's a recipe for 4 dozen cookies. But sometimes I only want to make 2 dozen cookies. So if I were to figure out how I'm going to cut this recipe in half, what would I do? Well, I would make half an egg. I would use half an egg, right? And I would use 1 stick of butter. And how would I cut 3 cups in half? Well, that would give me 1.5 cups, right? So what am I doing here for all of these problems? I'm dividing. I'm dividing by 2. How do I divide 1/2 by 2? Well, let's take it off the paper. What's half of a half? What's half of a half? It's a quarter. So most of us can do that in our heads, even though we don't really understand how we would write that on paper. Okay, so I know that 1/2 divided by 2 is 1/4. The question is, how do I do this so that it makes sense? This doesn't make sense to me. Well, notice that I said I wanted to cut the recipe in half. I didn't say I wanted to divide it by 2, but we kind of know it in our head. We already know it, that cut in half is the same as divide by 2. Cut in half is the same as divide by 2. In fact, anytime I divide by a number, it's the same as multiplying by a fraction. So 1/2 divided by 2 is the same as saying 1/2. I change it to multiplication, and I multiply by the fraction. Instead of 2, I multiply by 1/2. I flip the 2 over. This is 2/1. I flip it over and turn it into 1/2. That's how I get 1/4. This makes sense to me. This is confusing. So anytime I have fraction division, I always want to change it to multiplication. And remember that the way I change division into multiplication is I change the symbol and then I flip it. So this, remember, 2 is the same as 2/1. So when I flip it, it becomes 1/2. So here we are. If you look at this flowchart, now some people hate flowcharts and you can just skip it. But this is a handy reference on how I go about dealing with multiplying and dividing fractions. First of all, I can't do it by hand if they're in mixed numbers, so I want to rewrite them as improper fractions. For instance, if I have 1 3/4, I want to change that to an improper fraction. I don't want the 1 in front. This is really 1 plus 3/4. So it's confusing when I multiply or divide. So the way we do this is we multiply the whole number by the number on the bottom. So we do 1 times 4, and then we add it to the number on the top, plus 3, and that's our new number on the top. 1 times 4 is 4, plus 3 is 7, so that means our fraction becomes 7/4. Okay? 7/4. Multiply the number on the bottom, add the number on the top. So that's how we make it an improper fraction. Then I ask, is it division? If it's division, I change it to multiplication and flip the second fraction over. And then I ask if anything can cancel. So canceling is from that example that I gave earlier where I wrote 18 as 3 times 6 and 60 as 10 times 6. So 6 and 6 are the same, so I can cancel them. Now this is useful when I'm dealing with fractions with units. So if I have something that is inches over inches, units also cancel. I cancel units just like I cancel numbers. Okay, once I've done all the canceling, then I perform my multiplication, and then I make sure that my answer is in lowest terms. So let's do an example here. I'm going to multiply 1 1/6 times 9/20. So first I have to make this into an improper fraction, so I do 1 times 6, and then I take that number and I add it to the one on the top to get my new number. So 1 times 6 is 6. 6 plus 1 is 7, so that's 7/6 times 9/20. Now, this is multiplication, so I could actually write this as a single fraction. with multiplication like that. And I say, are there any common factors? Is there anything that goes into 7 and 20, or is there anything that goes into the top and the bottom the same? And what I have here is I have a 6 on the bottom and a 9 on the top, and so 3 goes into both of them. So before I do my multiplication, I'm going to divide the top by 3, and I'm going to divide the bottom by 3. So when I do that, 9 divided by 3 is 3. So I end up with 7 times 3. And when I do the bottom, 6 divided by 3 is 2. So I end up with 2 times 20. So this is a much easier one to do. I could actually do this in my head. 7 times 3 is 21. 2 times 20 is 40. So let me do this example for you here. Here I have 2 times 3/4. Now I'm just going to turn 2 into a fraction by putting it over 1. And then I'm going to say, do I have anything that can go into a top number and a bottom number? Yes, I do. 2 goes into 2 and 2 goes into 4. So again, I'm going to divide the top and the bottom by 2 first. So when I divide the top by 2, 2 divided by 2 is 1. So I get 1 times 3, and 4 divided by 2 is 2. So I get 1 times 2. So my answer for this one is 3 halves. So this is an improper fraction. If I want to change it into a mixed number, I have to divide 2 into 3. 2 goes into 3 one time, and I have 1 left over. So I write that on my fraction. Okay, dividing a fraction by a whole number. Remember, division, I want to change it to multiplication. So first thing I do is change my whole number into a fraction by putting it over 1. And then I change my division symbol to a multiplication symbol, and I flip the second fraction over. Now, if I didn't want to divide the top and the bottom by 2, I say I just want to go ahead and do my multiplication. I get 2 over 12. But this is not reduced. It's not in simplest form. So I'm going to divide my 2 by 2, and I'm going to divide my 12 by 2. Why do we care about this? So say you're measuring something, and it's 3/4 of an inch long. Would you really say it was 6/8 of an inch long? Do people talk like that? No, they say 3/4 of an inch. They say 5/8, 3/4, 7/8. They don't say 5/8, 6/8, 7/8. That's what it is, but people don't talk like that. People talk in simplest form. So that's why this is important. Now, your calculator will do this automatically for you. Okay, so how many quarters are in a dollar? I want to translate that to math. So a quarter is 1/4. So I want to divide 1 by 1/4. There are 4 quarters in a dollar. 1 divided by 1/4 is 4. Again, this looks really weird, but let's change it to something we know. Let's change the division to multiplication. Multiply, flip the second fraction, and it makes perfect sense. 1 times 4 is 4. So don't let this stuff confuse you. Just change any fractions with division into multiplication. Okay, another one, 5/8. Instead of divided by 2/3, we're going to multiply it by 3/2. Now, dividing by a fraction makes things bigger. Dividing by a whole number makes things smaller. That's important to remember. A lot of people just say, oh, division makes things smaller, but that's not true. If you divide by a fraction, it's going to make things bigger. Just like this. If I ask how many quarters are in a dollar, 4. Okay, addition and subtraction. This is where people have a harder time because we have to do this thing here, common denominators. You cannot add or subtract fractions until you have common denominators. And a really great way to think about that is if you think of a pie. If I have a pie and it's cut into 2 slices, and I have a pie that's cut into 4 slices, and I ask you how many, if I have this much of one pie and I have this much of the other pie, does it make sense to say I have 2 pieces of pie? No, because the pieces are different sizes. We want to make it so that both pies are cut into the same number of pieces. And then I would say I have 3 out of 8 pieces of pie. And I know that I'm doing things okay because all the pieces of pie are the same size. That's what common denominators means. It means cut the pie into the same size slices. Okay, so to figure out what the common denominator is, we want to know the smallest number that all the numbers in the bottom of the fraction go into. Oops, I didn't mean to cross that out. I meant to underline it. Okay, so for example, if I have two fractions, 7/10 and 1 out of 25, well, I want them to be out of the same number. I want them to be out of the same number. So what I do is I say 10, 20, 30, 40, 50. Hey, I know 50 is the smallest number that they both go into. 25 goes into 50 and 10 goes into 50. So that is my least common denominator, is 50. So I have something over 50. And I have something over 50. Now the question is, what happens to the number on the top of the fraction? So here's how we figure that out. 25 times what will give us 50? 25 times 2 will give us 50. So if I multiply the bottom by 2, I have to multiply the top by 2. So I end up with 2 out of 50. Over here, 10 times what equals 50? 10 times 5 equals 50. So 7 times 5 equals 35. So 7 out of 10 is the same as 35 out of 50. 1 out of 25 is the same as 2 out of 50. Now this website here has an awesome game for practicing making common denominators with pictures with pies on it, and I highly recommend you go to it. Alright, so we already made common denominators. Now let's go ahead and do our addition problem. So remember, you can't add or subtract fractions without making common denominators. So here's my question for you. If I ask you, how much is 1/2 an inch and 1/4 of an inch? Now, if you don't see it written down, can you do it? I'm betting most of you tell me right away that 1/2 an inch and 1/4 of an inch is 3/4 of an inch. But where'd that come from here? And the question you ask yourself is, oh, I have to make common denominators. 1/2 an inch is 1 out of 2. I need it to be out of 4. So how do I turn 1 out of 2 into something out of 4? Well, I know I would multiply the bottom of the fraction to make it out of 4. I'd multiply the bottom by 2. That means I have to also multiply the top by 2. So I would get 2 out of 4. Now if I rewrite that problem with common denominators, 2/4 plus 1/4, now it makes perfect sense. 2/4 of an inch plus 1/4 of an inch equals 3/4 of an inch. Again, we do this all the time in our heads. Trust yourself that you're capable of doing it, and you can do it. So we did this on the previous screen. Oops, 2. This is a 2. And that's a 2. And so I end up with 35 over 50 plus 2 over 50. So if I add these two fractions together, I get 37 over 50. Now, I have to warn you, I've seen people using a different calculator besides the scientific calculator. There's a special industry calculator that some of you have, you carpenters have, and those calculators round numbers. And so sometimes you'll actually get the wrong answer. Because if you're trying to measure something to a 16th or a 32nd of an inch, a lot of times they automatically round to a 16th of an inch. And so if you are trying to be really precise and you're trying to measure something and it ends up being 30 seconds of an inch, your calculator that you're using will round it to 15/16 of an inch. So, and that's incorrect. So please, if you want precision, use the scientific calculator and not your tool for your program. Okay, so that's all I've got for you, and good luck with fractions. I know you're going to do great.